So in this video, I'm going to go over in DMA 30, section 12 and 13. In section 12, here are some of the formulas that you would need to use when solving uh, the questions in my Math++. You need to know about sales tax and total price. This is pretty much typical day-to-day purchases. When we go to the store, whatever the purchase price is, we got to multiply it by the tax rate. Every state has a different rate. So once we know what the state rate is or the state tax is, we multiply them together. That gives us the sales tax. If we need to figure out, that tells you what the taxes is that we're going to be borrowing or purchasing. The total price comes where, well, now that we know the sales tax, we add it to our purchase price because obviously we have to pay taxes on everything, and that gives us the total price for whatever we're purchasing. Here are some more formulas. Here, the next one you're probably going to see in my Math Plus is commission. This is where commission is pretty much when you work at a job, and the job tells you a certain percentage that they will pay you times it by the sales that you produce. So, just for instance, if you are a car dealership and you sell, $100,000 worth of cars, or here they times it by whatever the percentages they're paying you, and that's your paycheck. So commission is pretty much is whatever you get paid. So the more you sell, the more paycheck you get. So obviously commission can hurt you because if it's really, really bad as far as sales goes or really slow in business, then they don't have anything to multiply by to give you a paycheck. Amount discount. So this is where we actually go to the mall or any kind of places where they have sales. So what we need to do is, in order to figure out the discount, we take whatever the percentage is. So when you see a shirt or shoes that are 40% off or 60% off, we take that and multiply by the original price listed underneath the shoe on the ticket tag. We multiply together, that's your discount that you're going to have. Take that discount and subtract it to the original price that's listed, and that gives you the sale price of what you pay out of pocket when you go to the cash register. So let's do a few examples from section 12. So here we're trying to purchase a plasma screen TV of 5,260. If the sales tax on the purchase price is $315.60, what we need to find out what the sales tax rate is. So here we're just kind of placing the information that we have inside the equation. So for here, their purchase price is 5,280. So this purchase price, 5,260. We're going to times it by the rate, which the rate we're trying to look for. So that's going to be our X. And it's going to be equal to the sales tax, which is $315.60. Now, in order to solve for this one here, because these two are being multiplied together, I want to do the opposite by dividing so I can get X by itself. So I take both sides here. The opposite of multiplication is going to be division. So I'm going to divide this number and come over here and divide it also. So that way this cancels out. And on this side of the equal sign, we have whatever this is equal to. And we'll go to the calculator. Let me write this problem down. So 3, 5, 6. All right, so we take it to our calculator, and we're going to say 315 divided by 5, and we get 0.06. Now with this one here, we have to actually change it to a percentage because the tax rate is a percentage. So in order to do that, we just take our calculator and multiply by 100, or you can move the decimal 2 places to the right. So the answer for this problem here is going to be 6%. So that's going to be the sales tax on this TV is going to be a 6% tax. So let's move further to commissions. Now with commission here, remember it's commission rate times the sales. So once again, we take our equation and we kind of draw arrows. A person earned $2,514.60 in commission. That's a big paycheck. So the sales that they were selling was $11,430 worth of products. What we're looking for is going to be the commission rate. So we're going to figure out how much the job is actually paying us. So that's going to be our X. So here, X times the 11,430 gives us what our paycheck is going to be. So once again, because both of these are being multiplied together, I'm going to take this number here, do the opposite, which is division on both sides. Write this one down. And we're going to go to our calculator. Type in the number 0.60. And then from this one here, again, 0.22. Remember, we're looking for a commission rate. So that means we got to times this by 100 to change it to a percentage. So we get 22%. So that cancels. So over here, all this is equal to 22%. So the last one we're going to look at is the amount of sale price and the amount of discount. So here's our formula again. So we're just pretty much placing the information that we know and don't know in the problem. Do we have the tax rate, the discount rate? We do. That's going to be 15%, but we're going to go ahead and change that to a decimal so we can go ahead and go ahead and multiply. The original price is $370. And that's going to be equal to, once we multiply those two together, 370 times 0.15, we're going to get $55.50. So the amount of discount is going to be $55.50. So this actually goes in this one as far as the answer in my Math Plus. So now we got to figure out the sale price. Well, the sale price, remember, is whatever we are buying, we take the discount and we're actually going to subtract it from it to give us our sale price, right? Anytime we go to the store, we want to get a sale on something. So we find the original price and we subtract the amount of the discount from it, and that's what we pay. So we take the 370 minus by $55.50. Let's go to our calculator. 370 minus, I can hit second and answer, because this here takes the previous answer I have here and puts it right here. And we get $314.50. So $314.50 for this one. And that gives us the sale price. So that concludes the examples from section 12. Let's move towards section 13 now. And in section 13, the first topic we're going to talk about is simple interest. This is where we use it for personal loans. Sometimes we use it on they use it on credit cards. Interest is pretty much, let's define the word interest. Interest is pretty much what whoever allows us to lend money, well, they have to get paid. Yes, they can lend us some money for loans, or you can charge up a credit card. But those credit card people and the bank people that gives you the loan, they need to stay in, they need to be paid somehow. And this is how they get paid off your interest. So the interest is pretty much whoever you are borrowing from, that's how they get paid. So the principal stands for the initial amount of money you actually are borrowing or charging, or even sometimes you're investing. If you invest some money into a bank, for a college fund later on, you grow interest on off of it, and then that adds on to it. So your money that you actually invested grows. So that's the initial amount. Any kind of dollar amount goes as to your principal. Then we're going to multiply it by the rate. Remember, the rate is always a percentage. So whatever the rate is, make sure you always change it to a decimal. And then time is one of the ones, the rule that you need to be aware of, because time always need to be represented in years. So if you have days, and I'll show you an example. I can find my examples. I think it's on this side. There it is. So for this one here, if something was in days, how many days are in a year? So we know it's going to be 365 days. If we talk about months, it's going to be 12 months. And if we're talking about years, that's actually the term that we actually need to be in, so we don't have to do any kind of changing. So for this example here, remember the simple interest is going to be interest is equal to the principal times the rate times the time. So interest is what we're looking for. Find the simple interest. Principal is going to be initial amount, which is 500. Multiply by the rate, change it to a decimal. So 11%, we change it to a decimal. And then time, because it's in months, I'm going to put 15 over 12. Remember, this has to represent years, always. So if this was, 65 days, you put this over 65 days, 65. So that's how you represent in years. So make sure you always represent the fraction as far as when the years is. Now, if this says 5 years, then you don't have to do anything in the fraction, because since it's already in years, you can just put 5 there. So this is where we need to be careful when you're doing simple interest. When you multiply everything together, you cannot multiply each one and then times it by 15. You got to put it over 12, because we're talking about months. And months represented for years is going to be 12 months. So we take all these and multiply them together. Times 0.11 times 15 divided by 12. And then our interest is going to be $68.75 for this particular problem. So $68.75 is the interest. So once again, to recap, if we borrow $500 from the bank, they're telling you that at 11% interest for 15 months is what you need to do to pay this $500 back. But once you borrow this 500, you also have to pay them $68.75. So them allowing you to actually borrow that $500, you have to actually pay them $68.75, which is going to be incorporated in your monthly billing to pay off that $500. So let's work another example. So Marcia agreed to borrow $8,000. So remember, that's going to be our principal. She has to pay it back in 6 years at a 12% interest rate. So remember, because this is already in years, I don't have to make it a fraction. This is good to go. It's in years. So we take all this and multiply together, and I'm going to go ahead and multiply it. Let's go 8,000 times 0.12 times 6. We get 5,760. Now, is this the final answer? This is where we got to read the problem real carefully. The question asks for find the total amount that she needs to pay back. This is only the interest that you pay the bank for allowing you to borrow it. Remember, the bank is not going to let you off the hook by borrowing $8,000 and just paying off this $5,000. Guess what? You have to actually pay back the $8,000 that you borrowed plus the $5,760 that you have to pay them. So once we add those together, we get $13,760. This is the total amount that she has to pay back. Now you ask yourself, is it worth it? Probably in the long run it is, because if she really needed that $8,000 to purchase something, well, there's no way she had that kind of money. There's probably not a chance that she had that money laying around somewhere or in the bank or even on our mattress. So that's why she had to go to the bank and ask for $8,000. But remember, the bank says, well, that's fine, we'll give you this $8,000. However, you need to make sure that you pay us also $5,760 for allowing you to borrow it. So it's a little bit of give and take there. Now let's move towards our last problem, and I think it's located right here. This is where we're going to talk about compound interest. So move this up a little bit more. All right, perfect. So let's go back to our slides here. So for the compound interest, this is where we're going to be finding out the interest over a long period of time. So before we just trying to find the simple interest right then and there, but this time sometimes we compound it for a long period of time. We're going to figure out what that interest is. So this is the formula. We have the principal in parentheses 1 plus r over n, and is raised to n times t. The only new letter that you probably don't recognize is the n. The n represents the number of times you are compounding. So within the problem, they'll tell you we're compounding annually, semi-annually, quarterly, or monthly. So what does annually mean? If I see the word annually, compounded annually, that means 1. So in here for n, and this for n, we're going to put 1. If it says semi-annually, then for this one here, we're going to put 2. Quarterly means 4, and monthly means 12. So let's work an example. The best way I would suggest when you're first starting off is to list the 4 letters that we're looking for. So here's my 4, 1, 2, 3, 4, and tell me the number that actually goes beside it. So in this case here, we have $3,000. That's going to be our principal, and an interest rate of 1.8. So remember, change this to a decimal. I know you see a decimal, but remember it's in percentage, so you have to change it by dividing by 100 and move the decimal 2 places to the left. So that goes here. The time is going to be 2 years, and then this here, it says is compounded what? Monthly. So the n will be 12. So here's this change to a decimal. My 12 is monthly, 2 years. I put all this in my calculator, and the amount after 2 years is going to be $3,109.88. So the trick is, remember, it's showing you how to put all this in your calculator, and there's 2 ways of doing it. You can do it step by step, or you can put it in all at once. Those of you that are newer to TI 83 or the 84 plus calculator, I would advise you just to do it step by step so we won't make any mistakes. Those of you that's a little bit more advanced and know how to work it, then you can go ahead and put the whole problem in it, into the calculator, and it produces the answer. So let me go to the calculator, and I'm going to show you both ways. So if you're looking to put the whole thing in there, we have to use some parentheses. So we have 3,000 parentheses 1 plus 0.018 divided by 12. And remember, you can use the alpha and then this part of this y equals to put this as a fraction. It does not matter. Now we're going to raise it. This is our raise button. And then sometimes for certain calculators, I think the 83, you need to put it in parentheses. But for the higher tech ones I'm using now, you really don't have to, but it doesn't hurt. And then drop it down here. So this is what the problem looks like all together in the problem, in the formula in the calculator, and we get the same answer. For those of you who want to do it step by step, we want to work inside out. So we still use the concept of please excuse my dear Aunt Sally. So we take this first part inside, 1 plus, and this time I'll use the alpha so you can see the fraction. And then 12. So here's my first part. I'm going to hit enter, get this answer. Now I want to raise this to 12 times 2, which is 24. So we can say raise that. So this answer, I just hit the raise button and automatically pops up the previous answer is what I want to raise to 24. And then we get this. The last step is we're going to come back and multiply by the 3,000. And you notice we get the exact same answer. So you can do a step by step or put it all in the calculator, whatever you're comfortable with. Let's do an example. So like I said before, we're going to come off to the side and write all our letters that we need. P, R, N, and T. So 4,000 is going to be the principal, and it's going to be, the rate's going to be 5%. The N is actually going to be quarterly, which is going to be 4, and then the time is going to be 5 years. So now that we have everything checked off, we just go through and put it into our formula, our compound interest formula. So 4,000 times 1 plus R, which is going to be 0.05, over 4, and raise it to 4 times T, which is going to be 5. So we figure out what this is going to be by putting in our calculator. So 4,000, 1 plus alpha, and then second, and then hit the number 1 to get it to a fraction. I think it was 0.05 over 4. Oops, hit the wrong button. Calculator. So 0.05, 4, close parentheses, then raise it to 4 times 5. We hit enter, and our answer is going to be, remember, everything has to be in money. So if we round this into money, it's going to be 5,128 and 15 cents, because money, we have 2 places behind it with a 100 spot. So we're going to round this 4 up because this 8 will make it go up 1. So this will be 15 cents. So this concludes DMA 30 sections 12 and 13. Please let me know if you have any questions or concerns.